Seventh grade honors, we continue with scientific notation. In a science lab, Dominic's instructor wrote the wavelength for violet light on the board as shown at the right. This was the wavelength. Is the wavelength for violet light a large or small value? And how do you know? We can say that it's a small value. It's a small value because it is much smaller than 1. And it's a very small decimal. How would you read the value using correct place value? What makes it difficult? Okay, looking at this place value here, that 4 is in the tenths, the hundredths, the thousandth, the 10,000ths, the 4,000ths, the 400,000ths position. So this is called 400,000ths. Which is not a commonly used place value. Scientific notation is a shorthand way of writing really small or really large numbers. Scientific notation is written as a product of two numbers, some number times another number. The first number must be between 1 and 10. And the second number must be a power of 10. A power of 10. Okay. In A and B, rewrite the value in scientific notation using the steps described in the table at the right. Okay, so here's how we convert standard, just the regular number, to scientific. So I should probably just fill in this first and then do these two examples. Create a number between 1 and 10 by moving the decimal. Count the number of times that you move the decimal. This number will be your power of 10. If the original value was greater than 1, the exponent will be positive. If your original value was less than 1, like a decimal, the exponent will be negative. So if we got this number here in standard notation, 6,980,000. In scientific notation, we're going to put the decimal between the first and second digit. We'll keep the 8. We'll drop all the zeros. And we'll make this times 10 to the, how many spaces do we move that decimal? 1, 2, 3, 4, 5, 6. 10 to the 6th power. And this one right here, this number in standard notation, this is less than 1, so we know we're going to have a negative exponent, okay? Because this number here is less than 1, it's going to leave us with a negative exponent. So let's put the decimal between the first and second digit. We'll drop all of our zeros, and we had to move this decimal 1, 2, 3, 4, 5, 6, 7, 8. 8 spaces times 10 to the negative 8th power. Okay, let's do one more right here. Convert each given value to scientific notation. Okay, let's put the decimal again between the first and second digit. We're gonna have 1.85. We're gonna drop all these zeros, but how many spaces did we move our decimal? We gotta move it 1, 2, 3, 4, 5, 6. just like that. Okay, I'm just looking over my answers real fast. Okay, so that's converting from a regular number, standard, from a standard notation to scientific notation. And now if we have to do it in the opposite order, that's what this side is for here. Okay, values represented in scientific notation can also be rewritten in standard notation. Okay, here's our steps to convert scientific to standard. Move the decimal the same number of spaces as the exponent. If the exponent is positive, move the decimal to the right, looks like. Okay. If the exponent is positive, move the decimal to the right in order to make the number larger. Add zeros as placeholders if necessary. If the exponent is negative, move the decimal to the left in order to make the number smaller. Okay, in A and B, rewrite the value in standard notation using the steps described in the table. Okay, so looking at this here, we know that this number is going to be greater than 1 because the exponent's positive. So we're going to make this number larger. The exponent's positive. We're going to end up making this number even larger. So it's going to be 425, and we're going to move the decimal 6 times. So if the decimal was here, we're going to move it 1, 2, 3, 4, 5, 6. So the decimal was here. We moved it 1, 2, 3, 4, 5, 6 times, and I could put in my commas here. So we end up getting 4,250,000. And this number here, our exponent, we can see is negative. So we're going to make this number smaller. We're going to make it less than 1. So that means we got to move our decimal to the other direction. We got to move our decimal to the left. So we're going to have 1, 2, 3, 4 zeros. And we got 5, 1, 3, 8. So just to check it here, we had to move from here, right? Move our decimal 1, 2, 3, 4, 5 spaces. And now we're left with 0.0000513 as our small number. Okay, let's do one more here. Convert each given value to standard form, like we did up here. So because this has a positive exponent, we know we're going to be making this number larger. We're going to make it much larger than 1. And that means we got to move the decimal to the right. So we're going to go 7, 8, 3. And we're going to add in at least 5 zeros. I believe it was 5. So we started right here, and we moved it 1, 2, 3, 4, 5, 6, 7 spaces. Okay, and now we can add in our commas, and we get 78,300,000. Okay, and that's all. So just follow your steps right here to complete the last few examples on your own, and bring me any questions you may have in class. Thank you.